Trig pre-college, Trig Identities. Not a lot of, all of what we're doing in this video, all the identities are going to come from the reference sheet that the Regents gives us. Really, we're going to talk today about some double angle identities, some half angle identities, and some sum and difference angle identities. So these four things right here we're going to be talking about today. All this other stuff on the reference sheet we'll do another day. Area of a triangle, we'll do a day on that. Law of cosine, we'll do a day on that. Law of sines, we'll do a day on that. Then you got your sequences in series, and you know your standard deviation bell curve on the bottom here. But today we're just focusing in on these four identity theorems. So let's look at our first example. If theta is an acute angle such that sine theta equals 5 over 13, what is the value of sine 2 theta, sine double theta? Now, I think what students tend to struggle with the most when it comes to these problems is knowing that it's an identity problem to begin with. So you have to really recognize when they say sine 2 theta, cos 2 theta, tangent 2 theta, you have to know that you need to go and look at this reference sheet and use this formula, because you can't do this problem without this identity formula. So we're doing sine double theta, and the formula for sine double theta is here. And in the reference sheet, they're using A instead of theta, and sometimes you'll see theta, sometimes you'll see X, sometimes you'll see A. It's all the same thing. It's just representing an angle. So sine 2 theta, 2A, is 2 sine cosine, 2 sine A cos A. So that, for this problem, is what we're going to use. So 2 sine theta cos theta. And this 2 sine theta, that's different than sine 2 theta. This is 2 times sine theta. This is sine 2 times an angle. So it's a different type of thing there. So what you're really doing is it's going to be 2 times the ratio of sine theta times the ratio of cosine theta. And we think of 2 over 1. So we end up multiplying 3 fractions, 3 ratios. And they give us 1. They tell us sine theta is 5 over 13. But what they don't give us is cosine theta. And so that's really what makes this problem, a problem, is, because if they gave us sine and cosine, we would just plug it in and solve. But usually you have to find something before you can get into that stage. So we have to find cosine theta. And so the best way to do that is they tell us that theta is an acute angle. So that just means that we're looking at a right triangle, and theta is one of our acute angles. And they give me sine theta is 5 over 13, so that's 5 over 13, and so now I need to find this other side in order to do cosine. And so this would be a Pythagorean theorem problem. This is a very common Pythagorean triplet. The answer is 12, but if you don't have that memorized, it's okay. You could do x squared plus 5 squared equals 13 squared, and you're going to end up with x equals 12. Okay, you don't need me to do all that algebra out for you at this stage, at least hopefully you don't. So now that I have this missing side in my right triangle, I know cosine theta adjacent over hypotenuse is 12 over 13. And so now that's really what a lot of these identity problems come out to be. They just come out to be simple multiplication problems. And so, excuse me, you can simplify things if you can, but really it tends to be easier just to multiply across the top, multiply across the bottom. So the numbers on top, 2 times 5 times 12, that's 10 times 12 is 120, and the bottom is 13 times 13 is the 169. And then you could type this into your calculator and try math, enter, enter to see if it reduces, but that is what they wanted here for the answer. All right, so next problem is talking about, says cosine A is 1/3. They want tangent half A. So you got to recognize when they give you a double A or half A and so on, reference sheet is where you need to go. So tangent half. This is tangent half. And let me take a picture of this and move it over so I don't need to memorize it. Sorry if that was a little loud. And let me just cut this and bring it over to this problem here. There it is. Okay, so this is what we're looking at. Notice that this formula, all we really need is cosine. Sorry, my tablet is acting a little weird. Looks like something's opening up. Just give me 1 minute. All right, so almost at here. All right, so let's see. We need, it's plus or minus in front of a radical, but they want the positive value, so I'm just going to pretty much ignore that. But it's going to be 1 minus cosine, which they tell me is 1/3, so 1 minus 1/3 over 1 plus cosine is 1 plus 1/3. So in the last problem, I had to find cosine for my formula. This problem, they gave it to me, so you actually don't need to do that in this. They gave you everything you need. Now, if they gave me sine here, then I would have to find cosine, so I was able to do this problem. Okay, so yeah, I'm sorry, I had to pause the video there and unpause it. You probably didn't notice because you're watching it all in, video time. But anyways, so they gave us cosine. That's all this problem needs. Substitute it in. 1 minus 1/3. You could do that in your calculator. You don't need a calculator. You could realize that 1 is 3/3 and you get 2/3. But I think a lot of you will probably do it in your calculator, which is fine. And 1 plus 1/3 is 4/3. And again, I could divide this in my calculator, or without a calculator, I can do the times a reciprocal thing here, and I'm going to end up with, simplify that, simplify this to a 1, simplify this to a 2. I end up with 1/2. So this whole thing can be done in our calculator. 1 minus 1/3 and 1 plus 1/3 will get me 2/3, 4/3. Divide them in your calculator, you're going to get 1/2. And so the square root of 1/2, when you do the square root of a fraction, you do the square root of the top and the square root of the bottom. The square root of 1 is 1. The square root of 2 remains rad 2 because it's not a square. And then we just need to rationalize this denominator real quick to get radical 2 over 2. So this problem wasn't bad because they gave us what we needed to plug in, and then the algebra is just a little tricky with the fractions, but with the calculator it should be pretty easy. A lot of these problems, you have to find something before you can substitute in. Like in this problem, they give us sine A is 4/5, tangent B is 5/12. So we're talking about two different angles here, A and B, and they want to know what is sine of those angles added together. But again, this is something you need to recognize as an identity. So I'm going to go back to my reference sheet. Sine A plus B, and that is this one. Sine A plus B is sine A cos B minus cos A sine B. So let me take a quick picture of that. Sorry if it's loud. And cut this over to this page. Okay. I'm going to rewrite this because it's pretty blurry and sloppy, but let's see. This is sine A minus B equals sine A cos B minus cos A sine B. Okay. Now let me get rid of that sloppy picture. Okay, so what this is what we've been doing. So I need sine A is a fraction, and it's going to be multiplied by cos B. And then I'm going to subtract that product times from the product of cos A and sine B. Now I have sine A is 4/5. So sine A is 4/5. And I have tangent B, but that doesn't go anywhere. So I need cosine B, I need cosine A, and I need sine B. So we have to do what we did on this problem, where I'm going to draw a triangle and use the Pythagorean theorem. But I actually have to draw two triangles because I need separate triangles for A and for B. So I draw one for A, one for B. And let's see, for A, I have sines 4/5, so that's 4/5. Pythagorean theorem will tell me that this missing side is 3. 3, 4, 5 is a very common one, but you could do Pythagorean theorem. And this other one for tangent B is 5 and 12, tangents opposite over adjacent, so I know those. Pythagorean theorem for this tells me it is 13. Again, that's a common one, but you could do Pythagorean theorem if you didn't know it. So that means cosine B for this is 12 over 13. Cosine A is 3 over 5. And sine B is 5 over 13. So let's see, if I multiply these, I get 48 over 13 times 5 is 65, minus 3 times 5, 15 over 65. I can subtract fractions with a common denominator. 48 minus 15 is 33 over 65, and that's my answer, 33 over 65. Okay, I know I'm at my 10-minute mark, and I don't like to go over this, but I want to do one more quick problem for you, and it really only will take a second, so just bear with me. Sine 210 cos 30 minus cos 210 sine 30. You need to recognize this as something like this. So what identity has sine cos minus cosine? Well, that's actually what we just did. This is sine cos minus cosine. It's the sine A minus B identity. So this is simply looking at the sine A minus B identity, where this is acting as AB. And so, right, I mean, it's AB and then probably B, AB, AB. Yep. Yeah, this is A my B. So this is sine 210 minus 30, which is sine 180. Sine 180. And I could simply type in sine 180 into my calculator, or I can use the concept that I know that 180 is right here, and that is the point -10, and sine is the y value of that, and so I'm going to get that. But I think most of you will probably just type sine 180 into your calc. All right, sorry for the long video this time. See ya.